Alright, gang, here we go. This is Chem 1, Unit 6, Part 3. We're talking about dimensional analysis. Alright, so dimensional analysis is essentially a tool that chemists and scientists, mathematicians use to help them convert units. Okay, you've actually already had quite a bit of practice with this, so this would be a little bit of a review of what you're doing and just a little bit of a new application of it, but the general technique should be should generally be known. Like you should already have a good handle on most of this. Okay, so another thing, so dimensional analysis, another thing people call it, you might hear, is funny forms of one. Okay, because we're essentially using ratios that allow a one-to-one conversion. All right, it's kind of the idea of that. So anyway, so steps, you're going to start with writing down what you know, and then from then on, you're going to let your units be your guide. So if you think about Pinocchio with the little cricket, let your units be your guide. All right, so some examples. So how many yards are in 10 feet? All right, well, you should be able to just say, oh, well, there's 30, there's, for every 3 feet, there's 1 yard, right? And so you should be able to, like, well, there's 3 1/3. But anyway, so, or we can use it with dimensional analysis. So we're going to start with what we know, which is the 10 feet. Okay, and then we're going to draw a parentheses for the step we want to go, and we're going to put what we start with in the bottom so it cancels, right? Remember, in fractions, if you have something like 8 over 1 times 1 over 8, these 8's cancel. Remember this? They cancel and you end up with just 1 over 1. Right? So anyway, so this is the feet will cancel, and then we're going 2 yards, right? Because this is how many yards. So the feet will cancel. Well, how many feet are in each yard? So for each yard, there's 3 feet. So we'll go, so it'd be 10 over 3 yards, which would be equal to 3.33 yards. And if we were thinking about sig figs, how many does this have? Well, this has 1 sig fig, so really the answer would be 3 yards. All right. Okay, how many seconds are in a workday that lasts exactly 8 hours? Okay, so we're going 8 hours, so we start with hours and we're going 2 seconds. All right, now you might know exactly how many seconds are in each hour, or what we could do is we could go to minutes first. So let's do that. We're gonna go. So then we're gonna make this a 2-step. So our first step is we're going from hours, right? Because our hours are here, so we want our hours to cancel, and then we're going 2 minutes. All right, so for every 1 hour, there's 60 minutes. And then we're going to, so now you can see that our hours have canceled, right? Our hours are here, but now we're in minutes, but we need to get to seconds. So we're going to put minutes in the bottom and seconds up the top. Okay, for every 1 minute, there's 60 seconds. So this would be 80 times 60 times 60. Anything that's on the top gets multiplied, and anything on the bottom gets divided. Okay, so it would be 8 times 6, so this would be 3,600 times 8. 3,600 times 8. Okay, so it would be 28,800 seconds. Okay, now think about sig figs real quick. This has 1 sig fig. Now remember, these guys here are defined values. This is a defined ratio, so they have unlimited sig figs. So this is the number of sig figs we care about. This has 1, so this would round to 30,000 seconds, and we don't want to have to count zeros, so this would become 3 times 10. Oh, but my face is probably in the way. So this would be, let's see, is my face in the way? I guess we could check. Yeah, so 2,800 seconds. So this would become, so it'd be 30,000 seconds, or 3 times 10 to the 4th seconds. All right? Okay. All right, so now we're going to do it, but we're going to convert things into, go to the metric system. All right, so instead of doing ratios that you're used to working with, like feet to yards, seconds to minutes, all that stuff, we're going to talk about the metric system. So remember, way back in part 1, we talked about the SI units. We talked about the metric line. Remember that? So pull out those notes. You're going to need that as we go through this. All right, so start with what we know. We're converting 55 centimeters to meters. So we're going to go 55 centimeters. We're going to go to meters. All right, so 55 centimeters. So we're going to put centimeters in the bottom and meters in the top. Okay. All right, so now what you're going to do is look at that number line you had. So remember our number line. Let's just draw this real quick. And I'm not going to write all the information. Let's see, we had mega, kilo, and then we had our base unit. This was our base. I'll put a big old capital B. And then we had deci, centi, milli, micro, nano, and pico. Remember that? Okay, so now the trick is what you got to do is you got to say to yourself, all right, which one of these is bigger? The one that's bigger is the one we're going to put a 1 with. Okay, so meters, that's our base, right? That's our base, so it's here. And then centimeters is over here, so this would be our centi. So anything to the left is always bigger, so meters are bigger, so we're going to put a 1 here. Now remember, this was 10 to the minus second. Okay, so that means we don't put the 10 to the minus second down here. What we do is we're just going to put 10 to the second. We never, as long as we put a 1 with the bigger of them, we don't ever have to worry about putting in the negative sign. That's kind of that's the whole power of it here. Okay, so really this is, and you also know that there's 100 centimeters in a meter. Most people know that. So this is the same thing. 10 squared is 100, right? 10 times 10 is 100. So we take 55 divided by 100. Okay, and this becomes 0.55 meters. Okay, and this has 2 sig figs. Our answer's got 2 sig figs, so there's our answer. All right, now we're going to do 750 decigrams in grams. So we have 750 decigrams. Okay, and we put our parentheses because we're doing dimensional analysis. We go with what we're starting with in the bottom, what we're going to in the top. Okay, so the decigrams will cancel. Okay, well, deci's right here. Grams is our base, so that means this guy gets a 1. And deci is 10 to the minus first, so that means we're going to put 10 to the first right here. So this becomes 750 divided by 10, which would become just 75. Okay, now think about sig figs. This is a trailing 0, no decimal point, so it's got 2 sig figs, so our answer can only have 2, so we just leave it as 75. All right. Now the last one says, how many kiloliters are there in 3.53 times 10 to the 5th liters? Okay, so we start with what we know, 3.53 times 10 to the 5th liters. All right, we're going 2 kiloliters. All right, so liters go on the bottom. Okay, kiloliters are going to go on the top because that's what we want to go to, so that's going to go on the top. All right, which one's bigger? Well, liters is our base. It's right here. Kilos are right here. So that means we're going to put 1 here. Now, one thing that I've noticed is that I've put 1 on the top of all of these. Don't fall into the trap of thinking that's how it always is. You're going to put 1 with the bigger of the 2 units. So in all these 3 examples, we just happen to have 1, the top one be the bigger of the 2. And then for kilo, remember this guy was 10 to the 3rd. So we're just going to put 10 to the 3rd. There's 1,000 liters in 1 kiloliter. All right, so this is 3.53 times 10 to the 5th divided by 10 to the 3rd. Okay, 10 to the 3rd is the same as 1,000, right? So 3.53 times 10 to the 5th divided by 10 to the 3rd, which really just becomes, remember, if you're dividing exponents, they get subtracted. So this would be 3.53 times 10 squared. Okay, and then we got to check our sig figs here. This has, remember, we only look at the coefficient. So this has 3 sig figs, this has 3 sig figs, we're golden, okay? And then our units here would be in kiloliters, okay? Now, this is where life gets more exciting. So this is dimensional analysis where we have more than one step, okay? So let's draw out our metric line again, okay? So here's our base unit, right? All right, base, kilo, mega, what the heck is mega? And then deci, centi, milli, micro, nano, pico. Okay, should get pretty comfortable with those. All right, you should be able to bust that guy out on your own. Okay, all right. It says how many micrometers are in 0.073 centimeters. Okay, so anytime you're converting between 2 things that are not the base, this is going to be a 2-step operation. Okay, 2 steps. All right, that means we're going to have 2 sets of parentheses. All right, so we're going to start with centimeters, 0.073 centimeters. All right, so for our first step, what we're going to do is we're going to convert it to the base unit. So we're starting here with centimeters, and then we're going to convert to our base unit, and then from our base, we're going to go to the micrometers. So we're going to put centimeters in the bottom, because that's where we're coming from, and we need it to cancel. Put meters in the top, right? Meters are bigger than centimeters, and this would be 10 squared. All right, and now we're going to go from meters to micrometers, and we're coming from meters because that's what we're at now, right? Because our centimeters cancel here and here, and we're just left with meters. So meters are here, and then micrometers will go up here, okay? And then now meters are here at our base, micrometers are here, okay? So that means our meters are bigger than our micrometers, and so this would be 10 to the 6th, all right? And so now our meters have canceled, and we're just left with our micrometers right there. So it would be 0.073 divided by 100 times a million. Okay, so 10 to the 6 divided by, so that would be 10 to the 4th, so it would be 0.073 times 10 to the 4th, and then micrometers. Okay, but that's not in scientific notation, so it's not quite good enough, so it would become 7.3 and 12 times 10 squared, the micrometers. Okay, nice. All right, and we check our sig figs. Leading zeros are never significant. This guy's got 2 sig figs. This guy's got 2 sig figs. We're Gucci. All right, now we're going from kilograms to picograms. All right, so we go 2.3 times 10 to the minus second kilograms. All right. Now we're going, this is a two-stepper, so we're going from kilo here to the base, and then from the base we're going to go to picos way over here. All right, so we go kilograms in the bottom because it's what we're starting with. Grams are going to go on the top. Kilograms are bigger than grams because it's to the left, and this becomes 10 to the third. All right, so our kilograms have canceled. Now we're in our grams. All right, now we get our grams to cancel, so we put grams here. All right, and we need to get to picograms. All right, grams are bigger than picograms, so we'll put a 1 down here. And picograms are really tiny. There's 10 to the 12th. There's a billion picograms in every gram. So this becomes 2.3 times 10 to the minus second times 10 to the third, right, because our grams cancel, times 10 to the 12th. So this would be 2.3 times 10 to the minus second times 10 to the 15th. So this would be 2.3 times 10 to the 13th picograms. And check our sig figs. This guy's got 2. Our answer's got 2. We're good. All right. And the last one here says how many feet cubed are in 9.35 yards squared. Woo! Ooh. All right. Well, so this should be fun. So this one's a little bit different. This one's not using metric at all, is it? So here's what I do on problems like this. So we say 9.35. We're going from yards squared, okay, and we're going to feet squared. All right. So this one doesn't really take 2 steps, at least the way I do it. So we know that we can convert yards to feet very easily, right? We know that there's 3 feet for every 1 yard, all right? 3 feet for every 1 yard. But this is squared, so we're just going to square this whole jobber there, okay? So anyway, so this would be 9.35 times 9, okay? I can't do that one in my head very easily, so times 9. So this becomes 84.15 feet squared, all right? However, this guy has 3 sig figs. Our answer only needs 3, so this would become 84.2. 84.2 feet squared. All right, so there's your answer for that one. All right, now let's take a step back and talk about why I squared this. I squared this because this yard here was squared, okay? And so I needed, this yard is not squared, so I needed that squared. But when I need that, put that square in there, it squares everything. So this becomes 1 squared, 3 squared, and then this squared also applies to these squares as well. And then that square will cancel, right? So then you get 9 over 1 feet squared per yard squared, all right? Last little bit here, converting complex units. So we say complex units because that means it's a combination of units, okay? So a car is traveling 56 miles per hour. What is the speed in feet per second, all right? Okay, so here we go. So we're starting with 56 miles per hour, okay? We're going to convert it to feet per second. So that means we need to convert our miles to feet, right? And our hours to seconds. So we're going to have to do a couple of steps here, all right? So, and you can start with the top or the bottom, doesn't matter. Let's start with the miles. So the miles are going to cancel if we put them on the bottom, and we're going to feet, right? So if miles go on the bottom, feet go on the top. For every 1 mile, we have 5,280 feet, okay? Now, so our miles are canceled, we're good, right? Because we're trying to get into feet, or we're in feet now. Now we need to get into seconds. We're going from hours to seconds, all right? So hours are on the bottom here. So if we want our hours to cancel, that means we need to put the hours on top over here. So it becomes hours up here, right? Hours are on the bottom, so that they get canceled with the hours that are on top. And then we're going to put minutes on the bottom, right? So for every 1 hour, we have 60 minutes. And then we got to do the same thing to get into seconds. Minutes are what we need to cancel, so we're going to put minutes here, okay? And we're going to seconds, and there's for every 1 minute, there's 60 seconds, all right? So the hours cancel with the hours, the minutes cancel with the minutes. We're left with feet per second. So we get 56 times 5,280 divided by 60 divided by 60. We get 82.13 repeating. Now this only has 2 sig figs, right? So our answer just gets rounded to 2 sig figs. So that'd be 82, and then it would be feet per second, right? Pretty exciting. And we box our answer, and we're good. All right, density of a substance. So we'll talk about in the next video exactly what is density, what does it mean. But for now, we're just going to run with these are the units for density. 7.21 grams per centimeter cubed. It says what is the density of the substance in kilograms per meter cubed. All right, so this is using metric stuff again. So we got 7.21 grams per centimeter cubed. All right. And we got to convert our grams into kilograms and our centimeters cubed into meters cubed. Let's do centimeters cubed first. All right, so we know that we need our centimeters to cancel. So we're going to put centimeters up here, and we're going to meters. All right, and we know that we have 10 to the squared centimeters for every 1 meter, but we know that it's centimeters cubed, so we're going to put a cube there. Right? And remember, just like that one from last slide, that cube is going to distribute across to everything else. All right, and then, so that gets us to our meters cubed on the bottom, and now we got to go to kilograms. So we're going to put this guy here. All right, so for every, we have a gram, and we're going to kilograms on the top. Kilograms are bigger, so this guy gets 10 to the third. All right. And so let's just double check our units. So centimeters cubed will cancel with our centimeters cubed. We'll be left with meters in the bottom, meters cubed. Grams will cancel with grams, and we'll get left with kilograms. All right, so when you plug this into your calculator, it'll be 7.21 times 10 squared to the third divided by 10 to the third. You get 7,210. All right, 7,210. All right, but this has 3 sig figs, so if we write 7,210 kilograms per meter cubed, this has 3 sig figs, right? Because trailing zeros don't have any sig figs unless there's a decimal point. So this has 3, this has 3. So that's an acceptable answer. But if we were cool kids, we'd write it in scientific notation. So we have 7.21 times 10 to the third kilograms per centimeter cubed. All right? Cool. So that's dimensional analysis, all right? So make sure you do lots and lots of practice problems. This is one of those skills in chemistry that you are going to use just about every day from now until the end of second semester. All right, so it's a vitally important skill to master now before you have to worry about doing real chemistry with that skill. All right, so do it now so you understand how to use the tool so later on you can focus on learning the chemistry. All right, so go ahead and do lots of practice problems. Let me know when you have questions, and I'll talk to you later.